Welcome to Lead Programmer. Today we are going to solve the question, divide players into teams of equal skill. Let's understand this question with an example. So we have been given an array of integers and the length of this array is going to be even. We have to form teams out of this array and each team should have two players. So in the given array, we want to find teams of size 2. How many teams can be formed? Well, it would just be the number of players that are available to us divided by 2. So that's how many teams that we would form of size 2. So in this case, it's 6 divided by 2. That's going to be 3 teams. Now we have to select players such that the skill level of each team is equal, which means out of this given array, we have to select players or we have to select skills such that the sum of the skills of each team are equal. How can we do that? Well, if you look at the numbers carefully, one way to form teams is find the first team can have a skill of 1 and 5, the second team can have a skill of 2 and 4, the third team can have a skill of 3 and 3. The reason being the sum of each of these teams is 6, hence they are valid. And at the end, we want to return the chemistry of the teams. The chemistry of the teams is defined to be the sum of the product of the skills. So that being said, the product of the skills in the first team is 6, the second team is 8, the third team is 9. So if we sum these numbers up, the total chemistry comes out to be 22, and that's what is returned. In case we weren't able to form teams of equal skill, then we would just return -1. So having understood the question, the first thing we want to think of is how do we find the skill of each team? Well, that's easy. We know that for the first example, we have 6 elements or 6 players. Each of those players have a certain skill. So the total skill available to us is just the sum of the 6 skills we have. And in this case, it would be 18. So if we sum everything up, we get 18. And we know we want to form 3 teams. So we want to divide the total skill available, which is 18, into 3 parts. And that would give us a skill of 6. So each of the 3 teams would need a skill of 6 in order to fulfill our given criteria. And we can then try to form teams. Now the main question is, how do we form teams such that the sum of skill is 6? Well, we can recall the problem 2 sum that we have previously solved. There, we were trying to find 2 numbers such that it's equal to a particular number. The same concept can be used here, where we use a hash map to track the frequency of each of the elements or each of the skills, and then we traverse through the given array and try to pair up each and every number. So for instance, we would first encounter a 3, and then we would try to find, okay, if the first skill is 3, we want to try to find a partner for this. So the second skill would have to be 6, which is the target skill sum we are aiming for, minus the current skill, which is 3, and check if 3 is available in the array. Well, a second 3 is indeed available, hence we can pair up 3 and 3 into a group. The same thing over here. We then encounter a 2 and we ask if 6 minus 2, which is 4, is present. It is, hence we can pair those up. In case we encounter a situation where we cannot find a partner for a given player, then we know that we cannot divide players into teams of equal skill, and hence we return a -1. So let's summarize everything that we have observed and run it on the first example. So for the first example, let's try to simulate what will happen. So first we would try to create a frequency map, mapping how many times each skill occurs. And we would also try to find the target. The target would be the target skill of each team that can easily be found as described earlier. So it would just be the sum of the elements divided by the number of teams that are present. So in this case, it was 18 divided by 3, which is 6. And then we try to run through each and every player or skill available to us. So first we encounter a 3. So the 3 is the first player in our team. So since we already encountered a 3, let's first decrease it in the map. And then we ask is 6 minus 3 present in the array or the map? In this case, another instance of 3 is present, so we decrement the sum over here to 0, denoting that we pair that up, and then we move on. So here we check if the element we are visiting is already being paired up. In this case, it is not paired up since we have so if we have an instance of it remaining, so we try to pair it up. So first we decrement the sum, decrement the count here to 0, and try to find its partner. So its partner would be 6 minus 2, which is equal to 4. So we see, does 4 exist? In this case it does, so we decrement its count to 0, and it means we paired up. Now let's check 5. So we first check, is 5 already paired up? We can check that by its presence in the frequency map. In this case it isn't, so we can reduce its frequency and make it a part of a team. To find its partner, we check if 6 minus 5 equal 1 is present in the map. In this case it is, so we reduce its count and pair it up. We know that everything is visited, but we still continue the execution because while running we don't know if that condition occurred. So we process 1, but we check the count of 1 is 0, which means that we encountered an element which is already paired up, so we skip and move on. Same thing with 3, and the same thing with 4. They are already paired up, so we move on. At the end, we want to return its chemistry. So while we were pairing up, we could have just multiplied the elements and found the total chemistry. And if at any point we encounter a situation where we cannot pair up a particular element, then we can immediately return -1. So let's look at this in action. So first we try to find the skill level of each group. As mentioned earlier, we could just find the sum of the skill divided by the number of teams available. And we can do a quick check to see if the skill that we calculated is not an integer, then we can straight away return -1, because we are given that only positive integers are present, which means that each skill that we can have should be an integer. It cannot be a decimal number. Next, we construct the frequency map that we saw earlier, and then we start processing each and every element in the skill array. We also initialize chemistry because we keep adding the chemistry as we pair up. So first, we check if the number encountered or if the skill encountered can be paired up. If it cannot be paired up, we just skip and move on to the next number if available. But if it can be paired up, we first reduce the count in order to mark it as being part of a pair, and then we find the skill we are searching for. If we are not able to find the skill in the map, or if the skill is available but its count is 0, then we immediately return -1 because we cannot pair up the number that we are trying to pair up. If it isn't, then we reduce the count to indicate that it's been paired, and we increment the chemistry to be the product of the two. If everything goes well and we don't return -1, then here at the end we just return the chemistry. The overall time complexity of this algorithm, as you can imagine, is linear because the only thing we do is go through the arrays, right? So we first try to find the sum. That's a big O of n operation. Then we try to find the frequency map. That's a linear operation. And then we go through each and every number. That's a linear operation, with each of the operations within that loop taking constant amount of time. So the overall time complexity is big O of n. The space complexity, however, can be said to be big O of the number of skills available. I don't mean the length of the skills array, but I mean the possible values of skills that are possible. The reason being, each element in the skill array represents a skill, and that's what takes up space in the frequency
Map.
array. So in the worst case, the number of elements in the frequency map would be the different skills that are available. In the given constraints, there are 1,000 skills that are possible. So skill can be a value between 1 and 1,000. So the space complexity becomes big O of 1,000, which is equivalent to a constant amount of space. Hence, the time complexity is linear, space complexity is constant. Hope you found this helpful. Don't forget to like and subscribe. See you later.